Hello, I am Subhendu Bhandari. Today I shall show you how to analyze the XRD result of a material if we have the data in any format which is supportable with Excel. So I shall use two softwares. One is Microsoft Excel and another software Fityk, which is freely available in internet. Let me start with Fityk. This is the Fityk software which I have installed in my computer. Let me load the data file. I have saved the data file in .csv format. This is the data file. Initially, the result will be opened without any baseline correction, which is shown in with green color. Before going for the baseline correction, I have to check whether linear has been selected over here or not. Then this is the baseline mode. I have to select the start and the end point. After selecting, this is the stripping of the background. After stripping, you can see the start and the end point will come in the same line, same horizontal line. Next, I have to insert the peaks. Before the peaks are inserted, we have to say whether which method we shall use for any peak fitting, whether it is in Gaussian mode, polynomial, cubic, Lorentzian or any other mode. So for our use, I shall use today Gaussian mode. Remember, the sharp peaks will be appearing for the crystalline domain and broad amorphous halo will be appearing here, maybe here, maybe here. To assign the broad amorphous halo, we can consider the crest of this part as the peak position of the broad amorphous halo. Okay. Let me insert the crystalline peak. Here is also another peak. Here might be one more. Now we are fitting, run. After fitting, in this case, if something goes wrong, it can go towards lower in the negative direction, which shows the fitting is not proper. So let me delete some of the peaks. Okay, let me delete the peaks. Once again, I have to include those peaks. Still one more peak is left. Yes, now it appears to be nearly fitted with the original graph. The yellow graph is the fitted and smoothed graph. Red graphs shows the deconvoluted peaks of under the graph, and in this part it shows the deviation of the fitted graph with the original graph. So now we can consider the fitted graph is almost equivalent to the original graph, and we have to assign each and every deconvoluted peak as either crystalline or as amorphous halo. So this may be a crystalline, this may be crystalline, this may be a crystalline domain. It may be amorphous halo, it also may be amorphous halo. Now let me export the data with all functions. I've already written some of the points over here which I have to calculate. From 2 theta angle, we have to calculate the theta value in radian, then sin theta, cos theta. From sin theta and cos theta, we can calculate d-spacing if we have the value of lambda. So for this sample, lambda is 1.54 angstrom because copper K alpha was used. Full width half maximum, beta. For calculation of the beta, what is the starting point, what is the end point in degree, and what is the full width at half maximum in radian, intensity, and crystalline size capital D equals to K lambda divided by B cos theta, and area under the peak. Let me open the data file. Here we can see it is not delimited. All data are placed side by side. So I have to choose delimited over here. Next, space, comma, semicolon, all these I've included and finished. X is the 2 theta values, Y is the fitted graph, S is the unfitted and unfitted in original graph without any baseline correction. This is the smoothened graph, and after that all those peaks will be for each and every crystalline as well as amorphous halo as individual deconvoluted peaks. So let me check. Yes, this is the baseline corrected peak without smoothening. This is the peak, this is the graph without baseline correction. So this is the original graph. This is smoothened graph, and after that this is the first peak. So let me zoom it. Okay, what is the 2 theta value of the peak? It is nearly 20.3. So the for the first peak, 2 theta is 20.3. What is the intensity? Peak intensity is what is the intensity? Peak intensity is 427. So full we have to check what is the full width at half maximum. So maximum value is 427, its half is 213.5. So nearly 213, it may be considered as 213. Yes, near 213, it is around 18.96. 2 theta value is 18.96. Near 213, the end point is 21.415, or we can consider 42, 21.42, 21.42. I'm sorry, this will be the starting point, this will be the ending point. What is the full width at half maximum? Remember, all those two are in degree, and these are the 2 theta values. So the difference is this is in degree. I have to convert to radian, multiplied by pi divided by 180. So what is the theta value over here? Theta is 2 theta multiplied by pi divided by, I have to divide by 2 to get the value of theta, 2 multiplied by 180. So theta divided by 2 multiplied by pi divided by 180. Sin theta cos theta now for n equals to 1, I can calculate d spacing as lambda divided by 2 multiplied by sin theta. What will be the crystallite size? Remember, lambda is 1.54 angstrom for copper K alpha, because for this sample we have used copper target, we have to use lambda equals to 1.54 angstrom. For these polymeric materials, K is generally considered as around 0.9, 0.94. So for this case, I have considered 0.94. If it varies, we can use any other value. So the value of K multiplied by lambda divided by B multiplied by cos theta. So this is the crystallite size in angstrom. So for this peak we have calculated D spacing and crystallite size. Now we have to calculate area under the peak also. Remember, we have to calculate all the areas under all the peaks, and after that we can cumulatively calculate the crystallinity of the material. For each and every individual peaks we can calculate D spacing as well as crystallite size. Yes. What will be the area under this peak? Let me show you. For example, for any graph of y versus x, if this is a graph, then how can we calculate the area under the graph of it? At any point, if we take a very small slice of a small part of it, then we can consider within any small distance the graph will be linear. So what will be the area of this structure? If this point is A1, if this point is A2, if this point is B1 and this point is B2, then for B2, B1, A1, A2, it will be the average of the rectangle B2 A1 A2 and B1 A1 A2. These two, for these two rectangles, if we calculate the areas, and this will be the average of the area. So for this, the area will be 0.5 because of the average, multiplied by A2 minus A1 multiplied by B2 plus B1. Else we can calculate also the whole area, and we can deduct the area of this part also. It will also give you the same equation. This equation we can use to calculate the area under the peak. We can put the formula over here, 0.5 multiplied by A2 minus A1, which is the 2 theta values, and multiplied by what will be the B2 and B1, because for the E column it will be E2 plus E1. Remember, in this case there are lots of fluctuations, where many of the cases it will show negative value. So we have to add ABS, which will give the absolute value. Now extending towards the end of the file, we shall get area under the peak of each and every point under the graph. Let me check it once again, whether it is E1 or E2. No, it will be, I guess it is F, because there is something wrong. All the values are the same. Yes, this is the peak, so it will not be E2, it will be F2 and F1. If the values are very less, some of the values are beyond the range of counting. So what will be the total area under the graph? Sum of the first to the last cell and bracket closed. This will be the area. So this is the area of the first peak. What is the area of the second peak? Just we have to change the cell numbers. Instead of F, I have to put G, and I have to change the values for all cells. This is the area under the peak for the second peak. For the third, it will be H, H1 plus H2, extended towards the last cell, and this will be the area. Then 3 3 more are left. For the next peak, once again I have to include this peak also. I can write it by using the keyboard, otherwise I can write it by dragging it. Yes, the values are very less, which is beyond the scope of count here, so we cannot calculate it here. It is so negligible. So for the last but one peak, we can consider it as negligible. Here also values are so less that the total value is negligible. It is very less. For first 4 peaks, we could have calculated the areas under peak. So likewise, if we calculate the 2 theta value, full width and half width value of the first and the last position, then we can just extend the cell for the next values, then it will be automatically calculating. So for the next peak, let me insert the peak here. 2 theta value is 27.14 and 528 is the intensity. 27.14, 528. 27.1, we can consider only one up to 1 digit, and what is the value of the intensity? It was 528 or 530. 530. 530. So half of it, 265. At around 265, what is the starting point in x-axis? To 65, 24.71. it is 24.71. End point is 265. We can consider 29.11. 21.11. So likewise we can calculate D spacing, full width at half maximum, and from the Bragg's law and from the Scherrer equation we can calculate D spacing and crystallite size. After calculation of AD under the peak of the individual peaks, we have to assign which one is the crystalline, which one is the amorphous, and then we have to calculate the whole area under the peak of the crystalline region, whole area under the peak of the amorphous region, and we have to take the ratio of the crystalline area to the combined of crystalline and amorphous halo. So this way we can calculate, and we can calculate different parameters, and we can analyze the XRD graph by using Fityk and Microsoft Excel. Thank you.